In section 12.6, we are looking at what are called percentiles. You may or may not have heard the word percentiles. They are used frequently, especially on things like standardized tests. You all took a standardized test as you were going through school each year, and when you got your results, it probably said on there somewhere at which percentile your score fell. You will be given a table to use in order to find percentiles. The table that is in your book is what is shown here. And what happens on these is you have to know the z-score before you can find the percentile. So let's say that we knew we had a z-score of 1.2. Let's remember what a z-score is. It tells us how far above or below the mean/median that score fell. So let's say that you found that the number that you were looking at had a z-score of 0.2. Here is 0.2 on our table. So that means that the number that you had was 0.2 of a standard deviation above the mean. Well, percentile-wise, here's the percentile that goes with it. So what we know now is that if you have a standard deviation 0.2 above the mean or median, your percentile is 57.93. 57.93% of all data will fall below that number. What if you had a z-score of negative 1.1? Negative 1.1 is right here in your table, and then looking at the percentile to go with it, it's 13.57. So what that tells you is that if you had a z-score of negative 1.1, that 13.57% of all data fall below that. On example 1, we are told that systolic blood pressure is normally distributed with a mean reading of 121 and a standard deviation of 15. We are supposed to use the table to find the percentage of people with readings, and then question A is below 133. You always need your z-score first. So the first thing we're going to do is find the z-score for 133. You take the given number, 133, minus the mean or median, which in this case was 121, and divide that by the standard deviation, which is 15. This gives us 12 over 15, which equals 0.8. Now we know the z-score, or how many standard deviations this number is, in this case, above the mean. We can still see our table, so looking up here at 0.8, here is a z-score of 0.8, and the percentile that goes with it is 78.81. So percentile for 133 is 78.81%. This means that 78.81% of all readings are below 133. When you read the percentiles from this table, it always tells you how many are below. Question B asks us to find what percent of the readings are above 142. So again, just like we did before, first thing we have to do is find the z-score for 142. We're going to take 142 minus our mean of 121 and divide that by 15. So we get 21 over 15, which as a decimal is 1.4. Going back to the table, you find a percentile for the reading of 142 is 91.92% are below 142. But our question asks us how many are above 142. The entire range of percentiles has to be 100%. So anytime you want to know above, you just take 100 minus your percentile that you just found, and you will get 8.08% are above 142. On example C, we are asked to find what percent of the scores are between 145 and 157. Find the z-score and the percentile for each one. So the z-score for 145, we're going to take 145 minus 121, divide that by 15, which is going to give us 24 over 15, which is, as a decimal, 1.4. Now going to the table, the percentile for 145 is 94.52%. Do the same thing for a reading of 157. Find the z-score for 157. So you're going to take 157 minus 121 divided by 15, which is going to give you 36 over 15, which gives us a z-score of 2.4. The percentile for 157 is 99.18%. We want to know what percent is between them. So to find what's between, we just subtract the two percentiles. We're going to take 99.18% minus 94.52%, and we wind up with 4.66% that lie between those two readings.